So, hello everybody. So, I welcome you in the lecture of microengineering. So, in this particular lecture, we'll discuss about, just a minute, I will check whether I am getting a proper view or not. Okay, just a minute. Yeah. So, in this particular lecture, today's lecture, we'll discuss about, just a minute, I will take pen. Yeah. So, we will discuss about HEMT. So, what exactly mean by HEMT? So, what exactly mean by HEMT? We will discuss about this. So, the last letter is nothing but transistor. So, this is lecture we have taken after the final year exam. I was quite busy in the final year exam, so that's why I have not taken the exam. But now I am free, so I can take your lectures. So HEMT we will discuss about. Okay. So if you are not subscribed my channel, please subscribe the channel. If you are subscribing, then you are getting the latest update of each and every video which I have uploaded on my YouTube channel. So just a minute, I will go to HEMT. So this is HEMT, that is nothing but the high electron mobility transistor. So high electron mobility. Okay. So I will explain each and everything to you. That is, what exactly mean by, you know, that electrons and electron. What exactly mean by electron? So normally we know that, suppose this is electron, silicon. Okay. So they are forming an covalent bonding with its neighboring atom. Okay. And we know that silicon is having 4 valency, that is nothing but the 4 electrons in the outermost atom. So I will give you an example. With the example, I will explain the concept of 4 and electron to you. Suppose this is electron, this is an atom of silicon, this is second atom of silicon. So what it will do? It will form an covalent bonding. It will form an octet. Okay, it will form what? It will form an octet in the form of covalent bonding. So this electron of first electron of one atom and second electron of this atom are forming an covalent bonding. So what will happen if I am bombarding a photon on this one, or if I am giving a voltage potential across this? So these are the chances to break the bonding of this one, break the bonding. So what will happen? It is assumed that after the photon bombardment, or we can say that after an potential given. So it is assumed that one electron will be free and one will be attached to it. Okay, one will be attached. So this, whatever the electron which is free, that is take part in the conduction. So we know that is nothing but the free electron, and that electron are responsible for the current conduction. Keep in mind that suppose you are having 24 electrons with you and 4 electrons are in the last orbit, so that are the valence orbit. So that electron are taking place in the conduction, and the remaining 20 electrons are there. They are forming, they are in the orbit itself. They are not taking place in kind of any conduction. Okay. So the 4 electrons are taking part in the conduction. So what will happen in case, just a minute, I will drop the portion, or I will erase the things. Yeah, it is quite long. So suppose now the case is different. That what is the case? That is nothing but, just a minute, I will check how many are live. Just I will check how many students are live. I think so. How many students are live? Okay, Aarti, I think she's live. Then Nikita. Okay. Yeah. Okay, how many are live? Just I want to check. Just I will check how many are live. Okay, so move. We'll move. So what will happen in this case? Just I will take again pen. So suppose this is a silicon atom. Silicon atom. So if and this is again a silicon atom. Okay. So if one electron is moving out of this barrier, okay, out of this what you can say the covalent bonding, I can say that the proper word is bonding. So electron moves, the vacant place is there. So if vacant place is there, so that vacant place is known as hole. It is known as hole. Why is it so? It is not at all electron. Keep in mind, it is not at all electron or not at all positively charged particle. So the vacant place, that is nothing but the hole. So why it is called as hole? Suppose if I want to place this electron, free electron back to this place, so the potential across this vacant space, it should be positive, because if it is positive, then and then the electron will get attracted, and that will get attracted when the same potential across the electron should be there, but it should be in the positive. So that is nothing but the 1.6 into 10 raised to minus 19 coulombs. This is the charge on an electron. So 1.6 into 10 raised to 19 coulomb is the charge on electron, but if hole is there, so its charge is 1.6 into 10 raised to plus 90. Plus 90, it should be charge on electron. Okay. So just a minute, I will rub this portion for you guys. Okay. So the high electron we have seen in the holes also. Mobility. So mobility is nothing but suppose this is the space, this is the silicon. Okay. And this is the starting end, this is the end. So electron, how fast is moving from one end to second end is nothing but the mobility. So how fast electron is there, that gives the speed of operation. Suppose I want to design a RAM. Okay, RAM, I want to play a game on my mobile, so I required a large memory, RAM memory itself. So that RAM is made up of the device whose electron mobility is higher one. Like GaS, gallium arsenide, is having higher mobility, okay, than the silicon and germanium. That's why we are using GaS for the RAM and other speed purpose devices. Okay, so this is all about what you can say HEMT. HEMT is nothing but high electron mobility transistor, HEMT. So where we are using? So normally transistors we are using for high speed operation, high frequency, and digital circuit and microwave circuit with the low noise application. Keep in mind, low noise application. For example, if I want to design a microwave device that is of some gigahertz, so we can't use normal transistors. We have to use such kind of devices which is made up of some material we have to see in the next slide. So this then the major change in the PN junction diode and this what you can say the HMT is that it is known as heterojunction. Okay, it is not having normal PN junction diode, it is having heterojunction. So what exactly mean by heterojunction is that suppose we are in a normal PN junction diode, this is P type material and this is N type material. Okay, and we are constructing this both P type and N type by using silicon either or germanium. either GAS, gallium arsenide. We can construct by using either silicon, either germanium, either gallium arsenide. But in this case, what we are doing, we are designing P by silicon and N by gallium germanium. So this, whatever the junction is called as heterojunction. Heterojunction. Keep in mind, heterojunction is kind of different things we are adding and we are operating a device, that is called as heterojunction. So the junction is made up of what? Junction is made up of different kind of material. Suppose this is silicon, this is GAS, this is GAS aluminum, or this GSP. Like this one, the heterojunction will act as. Okay, this is the construction of this. So normally this HEMT is nothing but, what you can say, HEMT is FET, field effect transistor. It's a kind of field effect transistor. So we know that what is exactly meant by field effect transistor. So as far as field effect transistors are concerned, there are three terminals, that is gate, main terminal, drain and source. So the current will go from this one and draining from this side. But there should be a role of gate, that is nothing but, if you are applying a potential across gate, so the junction will form and it will carry the current, high mobility current. The faster switching is operating over there. So if you are observing these two things, we are observing this, just a minute, I will rub the portion. If you are observing these two things, then here you will find N plus GS only, gallium arsenide over there, N plus GS, that is the high doping over there, and here we are using Al, aluminum and gallium arsenide over here. So this junction is different one and this junction is different one. Here you will find two, this is point is junction point, this is point is junction point, and you will find what you will find a material different, and here you will find a different material over there. So this is a simple construction of gallium arsenide over there. Okay, we have discussed about this. Some of the application of HEMT are there, that is we are using this for high speed application. Okay, and low noise performance is having, so they are widely used in the small signal amplifier, power amplifiers and oscillators and mixer for operating frequency up to 60 GHz. Keep in mind, 60 GHz is very high frequency. So if you are to operate this frequency, so we have to use the HEMT. Okay, it is kind of MOSFET, not MOSFET, it is FET device, field effect transistor over there. Then we can use this device in the radars. Okay, then DSB you can use, radio astronomy you can use this device. Then different kind of applications, such as nowadays HEMT are more usually incorporated in the IC circuits also. Okay, so this device is in the IC, so monolithic micro integrated circuits. This I think you have seen in the last RF subject, this MMIC. Okay, so that is nothing but the monolithic micro integrated circuits chip. So normally we are having the devices that are discrete devices. Whatever the devices are there are discrete devices, HEMT and all that. But if you want to incorporate the device in my IC, so it is very difficult thing, because ICs are small size and we have to attach more and more devices in between this. So it is very difficult task to anybody. So that difficult task is done by the monolithic micro integrated circuits. Okay. So this is all about HEMT. So I will stop over here. So thank you very much for attending this lecture. Thank you.